Hello friends, welcome to EK Lectures. In this lecture, we will be discussing the question number 57 from Karnataka set 2024. According to Born approximation, the elastic scattering amplitude. So let's write U of R equal to minus U naught by R e to the power minus alpha times R. It's not gamma, it's R, where u naught and alpha are constant, and the momentum transfer is q. Q is the momentum transfer. Now we have to find the approximation when alpha is tending to 0. Now the Born approximation for scattering amplitude is f of q is equal to or is proportional to integral e to the power I into q dot r times u of r d cube of r. And what is q? Q is the momentum transfer. Now we need to insert our U of R, and this is nothing but the Yukawa potential. Y-U-K-A-W-A, Yukawa potential. Okay. Okay. So it's proportional to integral e to the power I into q dot r u of r, where is u of r with a minus sign will come, u naught by r e to the power minus alpha r d cube of r. This is what we need to find, and this potential when alpha is tending to 0. When alpha tending to 0, we need to find this potential. So look at this, the integral e to the power I q dot r divided by r e to the power minus alpha r d cube of r. This is nothing but Fourier transform. Fourier transform of the Yukawa potential. The Yukawa potential. So Yukawa potential is this one along with R. So this is equal to 4 pi divided by q square. Now q we have here and alpha here, so q square plus alpha square. So f of q is proportional to 4 pi divided by q square plus alpha square. Now when alpha tending to 0, f of q is proportional to 1 by q square.